All right, welcome everyone. So first up today we have David Tello, Mad Engineer, going to show us his Linux-driven microwave. Please welcome him.
Thank you. There's a lot of you. I'm hoping to disappoint you all today. I'm hoping that it won't catch fire, but in the event that it does, the exits are on either side. I'll lead the way. So there's a number of problems with the microwave, particularly with my experience of microwaves. Popcorn gets burnt. Milk boils over unless you sit there and slavishly watch it. Defrosting a steak is really difficult without it sort of half cooking it for you first. The basic design of the microwave is unchanged since the 1960s. That's well before Linux, and actually it's before the first microprocessor. The only thing that's really happened is they've gotten a lot cheaper. They've tinkered around the edges. There's auto functions that nobody uses. There's an interface that requires a manual if you want to do anything complex, like set the time. There's a universal common design, particularly around the door, which has serious accessibility issues for people with physical disabilities. And trying to buy a left-handed microwave is almost impossible. My breaking point was I bought a cheap microwave. It happens to actually be that one. The buttons were so hard to push that when I dialed in the time, it slid across the bench. And quite a way, because to dial in the time, I had to push 4 buttons. Fortunately, to open the door was so hard it pulled it back towards me. So bad, my partner just refused to use it. So it was my first victim of exploratory screwdrivering. This is the solution that I came up with. So I started actually at the front with replacing the 4-character display with a proper screen. There's a touch screen to use it so that the user interface can change with the context of what you're trying to do with it. To back that up, I put a decent processor in there. I actually chose to put a Banana Pi in. The elements to the right-hand side are all the standard microwave elements that they come with. And then I tried to make it a little bit smarter. And to smarten it up, essentially you need to add sensors. So I added a thermal camera, which means that you can actually cook based on the temperature of the food that you're trying to heat. And I added a set of scales into the base of it so that you can weigh the food rather than having it prompt you for the weight in pounds. So the structure of this talk, I'm going to go through the software a bit, then I'm going to move on to the electronics, finally going into the mechanicals, and hopefully I'll leave plenty of time for questions at the end. So this is the very basic software structure that I chose to use. The GUI is a basic WebKit wrapper. The servers are actually all currently done through Python Tornado. There's a separate process to run a software PWM, but it's relatively simple. There's a lot of advantages to this structure. I confess it's not original. I stole it from Mr. Ferns. But it's very, very easy to develop. The GUI is simple. It's just standard HTML, CSS, JavaScript. And the server can be any scripting language. I've written similar systems in Perl and C. It gives you immense flexibility, though, structuring it like this. If you want to put in a remote web server, they just connect to the same WebSocket ports. This sort of hits the IoT checkboxes. Or you can hit all of the IoT checkboxes and strap additional servers in because the WebSocket layer acts as an add-on system for you. Anything can hook into that control server and know exactly what the microwave's doing and be able to control it itself. You can also hook in things like alternative accessibility clients so that people who need to access it through Braille or gaze tracking or voice systems or pretty much anything that you can think of can just be slipped in. So there's a number of features of the system that I've designed. I will just switch tab. So this is a live remote session into the microwave there. So you've got quick access to set the time. Often you just want to run it for a minute. So you just click on the minute and it fires up and runs for a minute. If the demo gods don't completely hate me. Come on, demo gods. So that'll run for 60 seconds, and you can adjust the time through the wheel and adjust the power level. And with a touch interface, that's all just one touch. You can do the same thing with temperature. If you want to heat something to 80 degrees, then you just hit the 80 degrees. The dial gives you the target temperature and the current temperature of the device. Again, it allows you to adjust things like the power. I cooked the microwave, the popcorn. It worked like 5 minutes ago. Anyway, the other thing that I'm, there we go. The other thing that I'm able to do when you put the sensors in there and you increase the smarts is that you can start introducing one-touch cooking concepts. So, for example, if I was to get a cup, fill it with a cup of milk, put it into the microwave, the scales are able to figure out that it's about 400 grams, which is about, a cup of liquid and the mug. The temperature sensor is able to see that it's about -5 degrees, so it's probably come out of the fridge. And even with a sensor this crude, you can get a rough idea of the size of of what's been put in. So I know it's relatively small. I can use these in a scoring fashion to score multiple entries. And for a cup of milk, I can conclude that what you most likely want to do is either boil it or heat it up. As you use the microwave, it'll remember locally what you've chosen, and it'll weight what you've chosen a little bit higher. But the idea is that you could simply put the cup of milk in, shut the door, it'll come up and ask you if you want to boil or heat. One touch, and off it goes. And it'll heat that up, wait until it reaches temperature, let you know, and then it'll actually hold it in a temperature band pretty close, so that if you're on the toilet or something, when you come back, it's still perfectly heated and waiting for you. Of course, there's more. You can get guided recipes, something where you have a sequence of steps which the microwave helps guide you through. The scales can help you weigh it, measure it, etc. The features like the one-touch quick cooking and the recipes and that kind of thing, I expect to leverage an online community so that you can upload you can write your own one-touch cooking recipes, upload them to a server, see other people's, choose to download them, that kind of thing. So onto the electronics. I'm an electronics engineer. So when I sat down and I started working on this, I quite consciously designed out most of the work so I didn't have to actually do anything. The standard microwave parts, like the magnetron, all just bought off the shelf. There's quite a number of vendors that supply that sort of thing. No interest in designing something like that myself. The processor board, I also chose to go off the shelf. The kind of quantities that I'm looking at about 500 for the first run of manufacturing. I'm using a banana Pi board. I got these in bulk. I can get these a year ago for under $30 per board. There's an equivalent board available now for under $15. I'm not sure I can buy the parts to make an equivalent system for that price. I certainly wouldn't be able to do the multiple spins and have the total cost come out cheaper than just buying something like this off the shelf. Some things I'm going to have to design. I'm going to have to design a relay shield which sits on top of the processor. That's most of what's currently hanging off the side there. I'm going to have to design a USB interface for the grid eye, which is the crap hanging off the top. The grid eye is the Panasonic thermal sensor that I'm looking at using. There is an open design for the grid eye that I will probably end up using. The scales will also require a bit of electronics, and with all the additions, I'll probably need to redo the power supply and filter. I expect that to be the most complex piece of electronics that I've got. Other things that I might end up doing, things like the door switch and the light, relatively simple, but might need to be done. One of the things that I'm hoping to cover in this talk is to try and inspire people to do something really, really silly and build something like this. So, a little bit dry. This is called the experience curve. This is a standard curve for manufacturing costs with electronics. So the idea is that if you make one unit, the price of one unit allows you to determine the price of, say, 1,000 units, because it follows a relatively well-known scale as you build more, and the price of one unit is determined by the complexity of the board, which is why everything that's complex I'm just going to buy, and anything that I'm planning on designing is very, very simple, sort of 3 or 4 components. I think the experience curve doesn't quite cover it. I think something like this is a little bit more accurate. As you go up in quantity, you get additional fixed costs coming in. If you're only building 10 boards, for example, you design the 10 boards, you get them built, you probably don't bother getting them tested at the factory, you just sort of make 14 of them. Because if you have to adjust, 2 or 3 boards by hand, it's really no big deal. If you're making 1 billion boards, you want to test that. 10% returns at 1 million boards is a really big problem. So you would tend to do additional manufacturing spins and that kind of thing. Going on to the mechanicals, manufacturing follows the same cost curve, but there's 2 different systems of manufacturing that you can use, 2 different techniques manufacturing that you can use, which was a bit of an unpleasant surprise for me. This is a turret punching machine. It uses a set of tools that it can choose from. and it moves the piece of metal around and fires many times a second. It sounds a bit like a machine gun working on the piece. This is really suitable for quite simple jobs. It's a low-scale manufacturing system because, as you can see, to build a panel like that takes quite a while. It's got to punch every single hole individually. The alternative technique is metal stamping. So this is a video of a BMW parts factory. Metal stamping is the large-scale technique. This microwave was metal stamped. All microwaves that you can buy commercially are metal stamped. If you're manufacturing 1 million microwaves, it's definitely the way to go. When you start looking at it, the cost curves look a little bit like this. I'm deliberately not putting numbers on these axes because it's going to change job by job. So turret punching is very, very linear. You set it up and you put one metal sheet through and you can get one product. And if you want 10, it's 10 times more metal and 10 times more time and 10 times more cost. Metal stamping is kind of the opposite. Once you're set up, the machines can just spit out a part once a second. The metal rolls through and it just fires out the other end. But that stamp that you saw is custom designed for that process. And that stamp that you saw in the video would be probably millions of dollars. So for developing a microwave, I was told that the crossover point was about 15,000 units. Was a rough estimate. So I'm stuck with turret punching and the relatively high cost associated with that. Fortunately, having to use a turret punch process rather than the big metal stamping actually gives us quite a bit of opportunity. For example, the reason why that you can never get a left-handed microwave is that all of the stamping presses are designed for right-handed microwaves, and the setup costs double if you want one that's left. Turret punching, because there's no real setup time or cost, if I wanted to make 10% of the microwaves open the other way, there's no real downside to me for that. Also, I can do things like introduce color choices, and looking at the lower scale techniques and the different materials that come with that lead to other opportunities, things like reworking the door on the microwave. So my preliminary plan is to have a metal and glass door with a fabric mesh in between. Because the mesh is not structural, I can have considerably bigger holes in it so that you can actually see into the microwave and see what's going on. Also planning on redoing the latch mechanism that the microwave works. The current latch design is actually regulatory driven. So the Australian regulations for a microwave basically just say, don't cook people standing next to it. The US regulations say that don't cook people standing next to it, but also if somebody opens the door, deliberately tampers with the door so that the microwave should still run when the door's open and stand in front of it. We want to stop that too. I'm not exactly sure why. I kind of figure that standing in front of an open-doored microwave is cooking yourself is the intention. But so the US rules say things like you can't poke a stick in and disable the door latch, which is why they have the curved arm. There must be two door latches, and it must be designed so that if one of them is closed but the other is not, then the microwave permanently disables itself. So it blows its own fuse, and that's why the fuses are actually always inside the microwave. It's the US regulations say that you have to actually get a screwdriver out to change the fuse. European regulations also say that it must be able to open and close a lot. So essentially that's why everyone's basically standardized on the same design or the same mechanism. And the most common failure mode for a microwave is actually the little micro switches that the door latch sits on. One of them fails. The microwave thinks it's been tampered with, blows itself up deliberately, and then nothing works. So what I'm planning on doing is actually going with a magnetic door latch. The US regulations actually mention magnetic door latches. So obviously in the 1970s they were a thing, but the regulations state that you can't glue a magnet to the door and have it unlock. Recent advances in magnets, I think, make it possible to revisit this. So you've got keyed magnets, which essentially put a positive and negative pole next to each other. You can also, multiple magnets, I think, will get through the regulation. And building the microwave out of stainless steel or anything non-magnetic actually also works because it won't support the magnet, which has just been stuck up there. Reworking the door so that it's easier for everyone to use also has some really nice accessibility benefits. So microwaves are used quite commonly with people with physical disabilities because they're easier to use than an oven. But the force required to open the door is quite significant for somebody who suffers from weak muscles. So it's actually quite a significant win for that space to rework the door and make it a bit nicer for everyone. Okay, time-wise. Ooh. So that's everything that I have planned, except I'm going to try and heat a glass of milk automatically. So as I finish up, I would like to grossly abuse my position as a speaker here and use you all for a survey. So if you come with me to Fantasyland for just a moment and you imagine that I'm Oprah, there's a stack of microwaves just outside the door. They're free. You just have to go out, pick one up on your way. Could everyone who would actually pick up a microwave put up their hand? Fantastic. Could you keep your hand up if we go to a slightly more realistic scenario and we say that there's a Kickstarter project for a microwave. There's a prototype. It looks good. It works. All the wires are inside the box. It's $100 Australian or $70 US. Who would take the gamble and go with the? Okay, that's pretty much everyone again. What it was 500 Australian dollars, 350 US. Right. So about half of you have decided that 500 is too much. 1,000 Australian dollars. So it's 7. one and a maybe. I know where he lives. It's all good. I was going to go up to 1,500, but there's only 2 people left. So, so at the moment, my indicative price is 1,000 Australian dollars. I am hoping to reduce that. Most of that cost is in the mechanical. So, my glass of milk is just done. A little bit hot, but...
He lives.
Oh, no, that's skim milk. I got it just before. Does anyone have any questions? I'll just repeat it. It's going to take a while.
In some ways, the lack of a buzzer is a significant advantage to products that seem to like beeping constantly. My dishwasher, for example, loves to beep once I open the door to tell me to turn it off. Not sure why it can't do that itself. Is the beeping just something that you plan to add in? Do you have any thoughts about that? I find this a frequent annoyance with devices, as simple as it seems that the BP feedback is super harsh or keeps happening, and is there anything regulatory about that?
There's nothing regulatory. I agree with you. I recently took a kettle that decided to beep at me every time I picked it up, and neutered it. The plan is to put a speaker in there rather than just a straight beeper. Speakers are quite cheap these days, and that allows me to beep. It allows you to customize it and have it play a little ditty for you, something a bit more pleasant. And it also allows... Yeah. And it also allows for things like text-to-speech, so that the microwave can, if desired, inform you as it's going exactly what it's doing.
Microwave recipe store could also have custom.
Yes, yeah.
And we can have someone else's microwave. Can you repeat that?
He would like to get access to your microwave and have it scream like a banshee remotely.
Yeah, I was also wondering, you've sort of designed your completely custom microwave. Have you thought of just getting like a standard microwave and just replacing the screen and all that sort of part at first, and then moving on to like completely custom?
Yeah, so I certainly considered that, and I looked at what I could get my hands on in terms of pre-made shells. And I might still go down that path. The big thing that I have remaining is trying to shake the cost out of the mechanical side of it, and that's certainly one way to reduce the costs. The reason that I'm going my own way and doing things like replacing the door, which doesn't mean that I can't use a shell that's standard, is that the ones that I could get my hands on all looked really bad, and they looked really cheap, and sort of sticking a new screen on something really cheap is just going to look really cheap. So given that I'm forced into the premium end of the market, I need a product that looks like it belongs up there.
Cool. Obviously, one of the first things on my mind with a microwave, as you say, is not leaking and irradiating the people around it. I have seen sort of interesting things with things like indium tin coatings on glass that reflect the, or reflect in this case, radio frequency radiation. But I was just wondering if you could tell us about the things that you've done for presumably the sensor in the top, for the camera and the sensor in the bottom, to for the scale and things like that, to microwave proof those.
So the easy answer is nothing. So, so first up, microwave radiation is not as scary as most people feel it is. Microwave radiation heats things. It doesn't cause cancer, for example. It's not known to cause cancer, for example. It doesn't break down the molecules. It runs at pretty much the same frequency as Wi-Fi. So a small bit of microwave radiation is really equivalent of sitting next to a Wi-Fi router. Yes, it will damage your Wi-Fi, which poses really interesting problems for trying to put Wi-Fi into a microwave. The way that the radiation works and the shielding works is that the wavelength is about 20 centimeters. So any hole that is smaller than 20 centimeters, and that can be a slit that's 20 centimeters long, but any round hole in particular that's smaller than 20 centimeters gets an exponential decrease in the amount of radiation that comes out as the hole gets smaller. So to mount the camera on this, I just drilled a hole that was a bit under a centimeter big and put the camera over the top. And so long as the hole is small, the radiation won't escape. Yeah.
With the community-provided recipes, would it be possible for some malicious actor to purposely set the thing on fire?
Well, yeah, I mean, if you said this is Jim's toast recipe, and you just turn the microwave on for half an hour, the toast is going to burn. So microwaves do have safety protections. If they do catch fire, there is a thermal sensor which isn't properly attached, which will when it gets too hot just cut the power to the system. So there is a safety built into them, but it's still going to smell bad and make your house stink.
I just wanted to ask, if you increase the size of the mesh in the window to be able to see it more clearly, how much are you able to increase that size and still prevent the microwaves from coming out?
As I was saying, the wavelength is 20 centimeters. Yeah. So anything, once you get below 20 centimeters, you start getting an exponential drop.
Okay.
So the mesh that they've got is crazy small.
Okay.
The preliminary one that I'm looking at has I think a 5 centimeter diagonal, which is the measurement that matters. It's sneaky. It rotates itself and tries to come out. But yeah, 5 centimeters I think should well and truly be safe.
Why do you think that they make it so small at the moment, as most microwaves have it around that size currently with the mesh?
I think the mesh is actually structural.
Okay.
As I was saying, everything about the microwave and anything that you think is a bit odd, the answer is always, in my experience, because it's cheap. And I think the way that they've done it is the mesh, the metal mesh, is actually the structural piece of the door, and the plastic around it gets its strength from the mesh.
Okay.
So the question was, a lot of fridge doors, you can swap it from left to right just by swapping the pins in and out. Because the microwave has a lot of requirements and regulations around the door latch mechanism, I think it would be quite difficult to do that. You would have to move the latch across, and the wiring loom attached to the latch, and that's 240 volts. And that's a little bit exciting to be getting an average user to do. My preliminary plan is essentially to take the front panel and roll it 180 degrees. Yeah. Yeah, effectively. But your current microwave won't work because the plate will fall out. So the question was, have I considered having some circuit in the door so that I can determine if the door is closed? Right. So have I thought about effectively putting latches on both sides and then detecting which way the door had been mounted? No, that's quite a nice idea, though.
So that was what I was going to ask too about metal in the microwave, and we're blocking the stuff getting from the food you actually want to heat.
Right. So the questions are essentially, can I determine whether or not I'm heating the vessel or the thing inside the vessel? The answer is no, not really. The sensor that I'm using, as you can see on the screen, is quite crude. It's roughly an 8x8 grid, and so for example, if you had a mug where the mug walls were really hot but the milk inside was cold, the mug walls would blind the sensor. So it would be very, very difficult to tell. But I think that's an acceptable. It's still a win.
Over here, I was meant to ask. It's a couple of questions. One is about the interfacing of the scales in mechanically. Is it got a turntable in that microwave, for example?
So that microwave does have a turntable. That's my backup microwave. The microwave that I'm intending on using is one more modelled on the Panasonic flat plate design. Which I actually have here as my spare, but the Panasonic isn't working too well at the moment. So that was my fallback position.
How you mechanically, with a turntable, I just couldn't see how to get the sensor in there for the scales.
Yeah, so the plan is to use a flat plate and have 4 pins on each corner, which go down to the sensors which are outside of the microwave cavity. And then the plate would move up and down slightly, and that would be the scale system.
The second question was whether the thermal camera, you could do something like tempering chocolate. Because if you could actually get a microwave that could temper chocolate, then I imagine that at least in the higher end market, that could be very attractive because, people who make their own chocolates probably are in the demographic that may be able to afford fancy microwaves, and it would be a feature that no microwave can do.
Okay, I've never tried. I've never tried tempering chocolate, so I'm not sure what's required. The very precise temperature control. So currently there's a bit of noise in the sensor. There's realistically there's 2 to 3 degrees noise in the system. If it needed to be more precise than that, then I couldn't make any promises. But yeah, I'll look into it. Thank you. Sorry, microphone's gone back.
I'm interested in how the resolution of the sensor affects for example, defrosting something consistently use case. Can you can distinguish for example, when you thaw out a piece of steak, you often have a frozen bit and a cooked bit. You can tell the difference between those with that sensor, can you?
Yeah, so the sensor can certainly spot between the frozen and the cooked bit. The plan for defrosting is essentially to rather than heat it to a certain temperature, as it have a certain temperature that when it reaches, it backs the power off. So that essentially the plan is to have a maximum of probably 40 degrees. And if any point of the steak reaches 40 degrees, back the power off until it all reaches, 30 or something. Yeah, there's enough resolution to see, a number of points on the steak.
Once you're done with your microwave, have you put any thought into rehydration machine from Back to the Future?
I have a list of alternative projects. That is not on the list.
This will have to be the last one, sorry.
Sorry.
Okay, so after the annoying beep, the next most annoying thing, left or right-handed, is the door swings out. You have to clear space in front of a microwave. Have you thought about a door that just goes straight up?
So vertical rising doors are actually fairly common in the American market. I'm not entirely sure why they're common there and not here. They often build them into the range hood, which seems to be odd to me, but that's what they do. So they're available. It's not something I was planning on doing because the whole lifting the door is a very different problem set. But if it's something you really wanted, I think it's something you can get now.
All right, well, thank you very much, David, for that. Can we please give him another round?
Thank you.